Hello everyone. So today we will discuss over chapter number 8, operating system security course, and this chapter is about protecting the network. So we have three main agenda items in this chapter. Starting with the network defense strategies, we'll talk about few network defense strategies, different tools of network, and vulnerability assessment. We'll talk about the steps involved in vulnerability assessment. Then we will talk about access control systems. We'll discuss AAA servers, and we'll discuss four main formal access control methodologies. We'll discuss the mandatory access control system. We'll discuss discretionary access control system, non-discretionary access control system, or also known as role-based access control system. And we will also discuss the a rule-based access control system, also known as attribute-based access control systems. Then we will talk about threat intelligence. So these are the three main sections of chapter number 8, starting with the network defense and vulnerability assessment. So there are a few terms that you need to know before we start the vulnerability assessment or the network defense. First of all, let's talk about few terminologies. So the first term is assets. Assets are basically the resources of organization which we are trying to protect. So assets are resources of company or organization, and these resources could be IT infrastructure. These resources could be your server resources, could be your information, etc., etc. And these are the resources which we are trying to protect. That is called asset. The second term is vulnerabilities. If you guys remember, we already talked about vulnerabilities. Vulnerabilities are basically loopholes, or you can say pitfalls, through which assets can be compromised. Okay, so assets can be compromised are basically vulnerabilities. Next is the threats. Threats are actions that can damage assets. For example, viruses, malware, or those kind of stuff are basically the assets. So in vulnerability assessment, mainly there are three steps. First of all, we identify and classify our assets. So first of all, we identify which are the assets, what are the worth of the asset to organization, what's the importance to organization or the business. Then we talked about we find vulnerabilities associated with those assets, and then last is the threats. We identify the threats. So firstly, identify asset. We identify assets, and then categorize them on the basis of their worth, or you can say value to organization. Like what are their value, for example, if that particular asset gets compromised, what will be the impact on the organization, stuff like that. So we categorize them depending upon, like, some could be critical, it could be asset could be less critical, or asset could be low critical, or you can say minor. Now the thing is, here's a very important thing. It's kind of an automated tool which is called CVSS, Common Vulnerability Scoring System. If you guys just Google it, so it will ask you a few parameters of the organization, and then you can assign numbers. So CVSS stands for Common Vulnerabilities Scoring System. And so you basically you can quantify your vulnerabilities. Like for example, if there is a major vulnerability, or for example more risk, of course it will be from 9 to 10, and then we have 9.0 to 10. Then we have medium risk. It could be from 6.9 to 8.9, something like that. So just look for CVSS and Google it and see what are the different scores with different parameters. Next is the identify vulnerabilities. After we have done with identifying our assets, so we are clear what are the assets of our organization and we know their worth as well. Next is the identify vulnerabilities and categorize the vulnerabilities as well. So identify vulnerabilities. So we need to actually find out the vulnerabilities. What are the different vulnerabilities? And after that, we need to find the characters who can exploit them and how they can exploit it. Next is the for example, if the vulnerability got executed, so what will be their consequences? So what are the consequences if vulnerability gets exploited? So if it gets exploited, what will be their impact to organization? What will be the consequences? Then we talked about the third step in the vulnerability assessment is identify threats. So next is identify actions which can damage the assets. So what could be the action? Action could be viruses. Action could be security attacks, like for example, SQL injection attack, cross-site scripting, etc., etc. So these are basically different three main steps involved in vulnerability assessment. To identify vulnerabilities, we use different kind of tools. Like one of the tool is Arachne. Another tool is OpenVAS. There is another tool, Nessus. There are plenty of tools through which you can find the pre-existing vulnerabilities. Of course, we cannot find zero-day vulnerability, but we can use these tools to avoid the existing attacks. To identify threats, of course, these are, after you find vulnerability, then we can identify the threats. Like for example, if you find there are website coding problem or web vulnerabilities, then it could be prone to SQL injection, it could prone to cross-site scripting. So depending upon what kind of vulnerability got identified, then we identify the threats. Now the defensive strategies. So in order to defend, we mainly use three main systems, there are three main network devices. One is the edge router. So edge router, it is basically a frontliner, or you can say a frontline device. And what it can do is it can validates traffic, or you can filter the traffic as well. You can use initial filter as well here. It validates the traffic. We actually use some formatters to avoid SQL injection, cross-site scripting, etc. These kind of attacks can be avoided by using edge router and by putting the formatter or validation portion. Number two, then the firewall comes in. So firewall, what it does, it again filters the data. You can define some rules. So it can we can put some rules. We can block certain traffic. We can block certain you can say certain format of the messages, etc., etc. The third is the internal router. That's the final check. Internal router, and this internal router equipped with IDS, intrusion detection system, and intrusion prevention system as well. Like if it detects any kind of abnormality, so intrusion detection system generates an alert, IPS then try to fix it or try to move it to honeypot or some other. So it's basically final check, and mainly does anomaly detection. If they detect any abnormal traffic, then they will use IDS to generate alerts, and IPS will be used in order to avoid it. This overall deep defense system is basically called artichoke. Artichoke, the vegetable artichoke, that's basically what we call this defense system. And the main idea of this defense system is For example, if any of the safeguard, any of the device gets compromised, so it should not, because these particular devices are independent. So if any of the device gets compromised, or for example can bypass, it will not affect the other system performance, because they are not interdependent on each other. Like for example, if edge router passed it, firewall will let it go. No, that's not the case. If edge router will pass it, firewall will do its own job, will validate the traffic based on the rules. Then after the firewall, when the packet gets to internal router, it will do its job regardless of what firewall did and all that stuff. So main idea is, if one safeguard fails, then it will not affect the working, or you can say effectiveness of other safeguards. Okay, it will not affect it, right? The reason is again that because these are independent, they are not dependent on each other. Then we have the organizational policies. There are different type of policies. Employee policy, which are basically mainly based on employees related details. For example, their salary and all that stuff. Company policy is basically a detailed policy, and that's basically defines the working of employees, like what employees, what are their code of conduct, what are the code of conduct for employers and all that stuff. So company policy is basically a comprehensive document. It's a comprehensive document that establishes the rules of conduct and responsibilities of employees and employers. Then we have security policy. There could be a comprehensive security policy which defines how to actually use resources. How it defines how to use resources, so CIA will not get violated. So I believe everybody is well familiar with CIA: confidentiality, integrity, availability. The comprehensive security policy, it has a lot of suite. Like it has the authentication policy. It's a part of the security policy. So a sub policy of comprehensive policy is the authentication policy. Then we have password policy. Sometime, like when your password will get expired. Of course, password is a part of authentication, but again, we can have a separate password policy as well, which is a part of authentication policy. Then acceptable use policy, like what you can do with organization resources, what you cannot do, etc. Then remote access policy, like the people who work from home, so how they can access the virtual private network and all that stuff. Then incident handling policy. These are basically the sub policies, sub suites, or you can say the main comprehensive security policy. Now that was all about, and these policies are basically very important to protect our assets, because if anybody violate any of the policy, of course, it will result in violation of CIA and eventually security breach. The second agenda item, or the second section, was access control system. So after authentication, the next level is, or next step is access control. Access control mean, let's say you just put your username and password. So after you put username and password, so there are a couple of resources owned by one organization. So you got authenticated, but you are identified as student, for example. So you can access Blackboard, but you have a different level of privilege. Who will decide that, like how much you can access? That is access control system. So access control system will define how much you can access the resources with your credentials. Okay, this is what access control system does. There are four main formal models of access control. The first model is called MAC model, which is called mandatory access control system. Mainly mandatory access control system is used in military and law enforcement, and it is the most restrictive model. The most restrictive model and mostly used in military. It usually involved some labels. So each device is assigned a label, and that label defines how much sensitive data might be in that particular device, or how much critical that particular device is. So if anybody wants to access that device, so they have to have a right level of security clearance, and then they will be issued the label. So let me explain you. For example, let's say what happens. Let's say, for example, we have a user Alice at the rate gmail.com, gmail dot, for example, gov. I'm just giving an example. Now the thing is, for example, if she has some level of clearances, so she can access might be top secret data. Maybe she can access, for example, a secret data. For example, restricted data. For example, there are some different tiers as well: top secret, secret, restricted. Um, let's say confidential data, and the last one is the public data, or you can say unclassified. Now the thing is, if Alice she has permission, because in the top secret there might be different kind of assert. Like top secret might be there might be top secret information regarding chemical weapons, for example, regarding, let's say, drones, regarding some other stuff. So let's say Alice she can access top secret information, but within top secret, what kind of badge she has? Let's say the compartment is chemical. So if she has that badge or that particular label on her account, so what she can, when she will she will log into the system, she can access top secret information. Within top secret, she can only access chemical weapon. So she cannot access other top secret informations. Another point is, if you want to access something from secret tier, like secret information, so she has to get that label as well. So it doesn't mean that if she has a top secret label, so she can access by default secret, restricted, confidential. No, she has to earn those particular labels as well. So that is why we call it. It involves a lot of formalities, and it is a very it is the most restrictive model, not suitable for the corporate world. Next model is DAC. It's called discretionary access control model. So discretionary access control model is basically least restrictive model. Least restrictive model, and we use that particular model in Microsoft Windows. In Microsoft Windows, and it does come with Unix as well. Like in the DAC model, the main idea is owner decide who can access the resource and how much they can access. For example, let's say you have your computer. Within your that computer can be accessed. Let's say you own this computer, but you have created 3 accounts in this computer. So it means 3 people can access that device. So you can actually, when you log in as administrator, because you own that, so you can create a folder on your computer, and then you can put, let's say, some secret information in that folder. Now the thing is, you want to allow only this user to access that resource. So you can set some permissions. It's very simple. You can right click the folder, go into the properties, select the security tab, and then you can set the different level of privilege. Like you can allow some user to read, some users can write it, some user can execute it only. So there are different level of privileges that you can send with Microsoft Windows. Next is the non-DAC. Non-DAC is also called role-based access control model. So depending on your role, you can, based on your role in organization, you can access the resources. So based on their roles, like your roles in organization, they can, like I'm talking about the employees, so they can access resources. Next is the rule-based access control model, usually used with dynamic organization. Dynamic organizations. And what exactly happens here? For example, if a small organization, dynamic mean where things change very quickly. Let's say rather than setting the proper roles, what we do in rule-based access model, we assign the set of permissions with the object. So let's say this is the object. We assign the set of permission with this object. Object mean the resource. Let's say it's a printer. So printer has the set of permission like who can access and how much that particular person can access me. So whenever, let's say this is the user, he wants to take a printout. This particular request will be intercepted by a device or software called security kernel. Security kernel will then check the rules of the object and see whether this subject or this user can access this object or not. Based on whatever the rules are, then kernel will allow or turn down the request. This is called rule-based access control model, where the rules are attached with the objects. So these are the 4 access control models, and how now we can implement that. So typically we use AAA servers, and AAA stands for authentication, authorization, and accounting. Authentication is basically verification, like whether the individual is who he or she claims to be, not an imposter. So ensures whether the individual is who he or she claims to be. So typically we use username, password for authentication. But we can also use multi-factor authentication, and we can use different factors for authentication, like sending a PIN code on the cell phone, stuff like that. Authorization is basically how much you can access. Like after authentication, now you got authenticated, you are a legitimate user, but how much you can access. Accounting basically start tracking activities. Like after giving you access, what you're supposed to access, you will be monitored. The system will start monitoring your activities. There are many AAA servers. One of the AAA servers is Radius. It stands for Remote Authentication Dial-in User Service. That's a server. It was basically introduced back in 1992, and it became telecom industry standard back in 1992. Perform authentication, authorization, and accounting to access the network resources. Let me explain you how Radius works. So let's say this is our user. So user want to access this particular access point. For example, Wi-Fi access point. User has a username and the password, but this username and password are not stored in access point. So let's say user want to access this access point, so user can start using internet. User will forward username and password, like if you go to motels or coffee shops, so something like that happens. It's called captive portal kind of approach, where you just put username and password or your receipt number. They redirect you to a website. So what will happen? You will be redirected to a Radius server, and that Radius server has a database of legitimate username and the password. So you just enter username and password. Access point will forward this to Radius server, where it will check for a match in the username and password in database. If a match occurs, then Radius server will allow a access point to give you services to get you connected, and then Radius server will. So that's the way how Radius in fact works. Then Radius, basically there are a few problems with Radius. One is it doesn't provide device authentication. Like you can bring your own device in the network, put the Ethernet cable back, it will start broadcasting the signal. Then it will not do all that kind of stuff. So no device authentication in Radius. Authentication. So the problem is people can install rogue access point. Other thing is username, only password goes in encrypted form. Username goes in plain text form. Plain text, like if anybody sniff that, they can see username. Only password goes in encrypted form, like hidden form. Then it basically use UDP ports for authentication and accounting. So mainly use UDP ports for authentication and accounting. The counterpart is the Cisco's proprietary. Cisco has came up with a different idea. It stands for Terminal Access Controller. Sorry, it's not terminal, it's total. Total Access Controller, Total Access Control System. It is absolutely same, like user ID will be forwarded to access point, will forward the username and the password to server, and the server will look for the database and all. Everything else is same, but both username plus password both goes in an encrypted form, number one. Okay, it is more common with Unix and accounting. The accounting and the authentication both are basically get done through the TCP port. Rest of the stuff is same. The last thing is the Kerberos. I have created another video for you guys for Kerberos. I will upload the video just for the reference, so you can understand what exactly the Kerberos is and what is the OAuth. So I have created a video for you guys. I will upload the video, and then I'll send you the link for that video. Kerberos is mainly used in single sign-on. What is single sign-on? Single sign-on mean, for example, at Gwinnett Tech, we have one main platform. Okay, dashboard. So we call it dashboard at Gwinnett Tech. Within the dashboard, we have banner, we have your email, we have, for example, Blackboard, we have many other stuff as well. But the thing is, all these products, all these services are not offered or created by Gwinnett Tech. So if you want to access Gwinnett Tech email, if you want to access, for example, banner, if you want to access some other services, Blackboard has, I mean, they have started offering for username and password, but I'm just telling you for simple understanding. So the thing is, you don't have to create different accounts for each and every service. Like email is managed by Microsoft, a different company. Blackboard managed by a different company. Banner managed by a different organization. The thing is, all you have to do is you just have to have one username and password, and you can access all these stuff. How it could be possible? Through Kerberos. How? So for example, when you send your username and password to a single, like to, let's say, username and password to Gwinnett Tech server, they issue you a ticket. Okay, and then if you want to access anything else, they just put some hyperlink here. Once you click, let's say, email, so when you click that, it will redirect you to Microsoft, and Microsoft asks you, hey, who are you? Then you present that particular ticket. Once you show them the ticket, they then allow you to access the resources. This is how the Kerberos work, where a third party authenticates you and then issue you a ticket, and then you can access the resources of different vendors under one roof. The last thing is the threat intelligence. For threat intelligence, we have many companies. For example, if you got compromised, for example, so there are plenty of agencies through which you can directly contact, like CERT, Community Emergency Response Team. There's another institute which provides free publication. There are a few good certification as well, trainings as well. SANS Institute, they provide very good certifications, very good. In fact, they have started offering the bachelor's and master's degrees as well in cybersecurity. So you can actually educate yourself from this institute. Other than that, Department of Homeland Security. So DHS, Department of Homeland Security, they have also started a free service, and their free service is called Automated Indicator Sharing, where you can actually, they share the real-time cyber threat indicators. Actually, they actually share that information. So they offer a free service named Automated Indicator Sharing. And what exactly they do? It's basically real-time sharing of cyber threats indicators. So by using that indicator, we can update our devices, we can update our firewalls, IDS, IPS, and all that. Other than that, there is another platform which is called CVE, Common Vulnerabilities Exposure. So it maintains a list of the vulnerabilities. So if you Google CVE, you will see there are plenty of vulnerabilities uploaded by different threat hunters, bug bounty people, or the pen testers, and each vulnerability has been assigned a number, a title, a number, CVE number, through which that vulnerability can be identified. So that's it about our chapter number 8. If you guys have any questions, please do reach me out. Thank you.